Welcome to our structural steel design masterclass. Today we want to learn how to create cool form steel members and import it to Autodesk Robot structural analysis provisional software database. Now, if you are someone that use Autodesk Robot structural professional, you realize that one of the challenge that we have in that software is the lack of availability of the cool form steel section. So sometimes we have to improvise, maybe use universal beam, or we use rectangular hollow section as the our Z pole line. So which to some extent might actually affect the load of the structure. So it is better that we use the right material that will be used for the construction to estimate the load on the building. So it is important that we create this cold form steel section and now use it in our modeling. So today that is exactly what we want to learn. So we are going to model the the cold form steel in AutoCAD and then save it as the Excel file. So when we save it as the Excel file, we will now go to the robot structural analysis professional software and now import it into the software and create a material for it, then save it so that we can use it as a set line. So that is exactly what this very model is all about. So let's quickly go to the AutoCAD. Okay, now before we move to AutoCAD, let's look at the section. The so we are using BS 2994 cold roll steel, cold roll steel as the member BS 2994. So we have here designation. We are going to use this. We have the designation which is D times B times C times T. So this is actually the depth. This is the width. This the C is the curve, the folded length, and T here is the thickness. T here is the thickness. And when you look at this, you have the mass to unit length in kilonewton per meter. And whatever that we are going to model, the mass over unit length, the weight of that material will fall within. For example, if we model this, if we model this, if we model this and import it to Autodesk Robot structural analysis, you will see that the weight will fall between 4 point something. It might not be exactly 4.31, but you see that the weight will be around 4 point something. So let's do it. Maybe if time will permit us, we are going to do it for about 3 different uh, cold roll steel sections. So let's go. So a new let me open a new drawing. Open a new drawing. So going to use we are going to model okay, let's model 150 by 50 by 20 by 2.5. So this will give us 5.31. This will give us 5.31. Okay, so we have the folded section. The folded length is 20. Folded length is 20, 50, then 150. So we start with that. So you go to polyline, click on polyline, When you click on polyline, we type 20, 20. Okay, sorry about this. We need to delete this. Okay, polyline 20. So we are taking this up. So we are taking this up. So we have 20. That is 20. Then the other one is 50. 50. Then followed by 150. 150. Followed by 50 again. Then followed by 20. Okay. So we have established that. So let's go back and look at the whole roll still, the shape of it. So we have done this. So now let's chamfer the edge. Let's chamfer the edge. So we come to fillet. You right click, go to radius. So the radius, we are going to use radius of 2.5. We use 2.5. Okay. So we are done with that. So let's let's define the coordinates. Let's define the coordinate. So come here, type 0, 0. When you pick a line, so you pick a line. So I will use this, then I'll move this, I'll move this, I'll move this. So I can now delete this out and also delete this one out. So I will go to save. I will save it in the Excel file, save as. So I will come to, let me come to, now let me go to, I'm already in desktop. Already in desktop. Let me save it into, okay, still. No. So I will save it into this folder. So I will say 150 by 50 by 20 by 2.5 mm. Z for line. Z for line. Click on that. So I will come to robot. Click on robot. I'm using frame 3D design template. So I'll click on that. So when I click on this, I will simply come to tools. Under from tool, I will come to section definition. When I come to section definition, I will click on new thin wall section. So when I click on that, I will come to file. From file, I will come to import the XF. So I will look for where I save it in my still template. So this is where I save it. I will click on open. When I click on open, it will show me this. So I have this. This is the shape of it. I say okay. Click on OK. So this is it. So this is it. So what I will do next is to highlight the whole of this. So when I highlight this, I will right click, go to properties, go to properties. Now I want to define the material. I want to define the material. So number one, under material, I'm going to use the steel grade 275. I'll click on that one, 275. Now the thickness is 2.5. Thickness is 2.5. I will click on apply, click on OK. So I've done that. Now let me check the result. Let's check to check the result. You simply come to geometry properties, click on result. So when you click on results, you now see here that we have weights of the material is about 5.6. So we have the density of steel, we have the young modulus, So here we have the center of gravity. So every other thing, the principal system, G everything. So we come back here. So we can now close. So we want to save this. So to save this material that we have just created, we come to go to file, go to save to database, save to database. So the database that we are saving it into is user. This, remember that this is user defined. So the name, so I can say that this one is let me call it ZP1, 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 which 150, 50, this is 20. So I'll click on, okay, maybe it doesn't need uh, ZP, okay, let me say ZPL, ZPL, ZPL. So for us to see that which we have defined, we come to structural model. So let's go to member. Under member, we come to these three dotted line. Come to this three dotted line. Then we come to family. Let's use user. Okay, under user. So this is how we save it. CPL. So this is it. This is it. So I can now add to this. I can add to this. And add to this. Can add to this. So you can now see that this is our Z. This is our Z-pole line. So you can see these are Z-pole line. These are Z-pole line. So you can see it. So this is what you can use as your Z-pole line. So when you are modeling either your portal frame, your trusses that will require the Z-pole line. So that is how you can do it. So you can do it for as many as you want. You can do it. You can do it for 150, for 150 by 2 point. We did it for this. And now when you look at that mass per unit length, you see that that mass per unit length was under what fall within 5 point something. I think our own was around 5.6, but it's still within the range of 5 point something. So you can do it for 150. Okay, let's try 150 by 50 by 2 by 20. Let's do that one at the last. Let's do that one at the last. Let me create a new one. So we go the same procedure. So this will be 20, 20, 50, 50, 150, 150, 50 again, then 20. Okay, so we have done that now. So we chamfer its radius 2.0. Okay, so we are done with this. So we can save. We can save. Okay, so we click the Excel file. So this one will be 150 by 50 by 20 by 2.0 mm by 2.0 mm Z for line. Okay, so we are done with that. So we come to robot, come to section definition, section definition, section definition. Let me okay, let me just start it. Let me go to new. Let me go to new project. Okay, yes. Let me just save that. Cool form, cool form, cool form. Still, cool form still. Okay, so this is a new project. So you come here, section definition. think we can delete this out. Okay, then we click here, section not saved. Yes, we don't need to save it. Let me just do this so that. Okay, so we come to import the Excel. So we have this one, open, look at it. Okay, so we highlight it, right click, come to properties. So this one we change this to H275. The thickness is 2 yes. So we apply and click on OK. So apply and click on OK. Then we come to result. Click on this. So you see that we have 4.5. So let's look at the weight of the section from the section table. 150 by. So you see we have 4.31. Then what we have here is 4.5 kilogram per meter, which is okay. Then we save this. Save to database. So user, so we call this one PZP ZPN because it doesn't accept figure ZPN, then 150 50 20. So we can now click on OK. Click on OK. So it has been saved to the database. So let's go to the structure to check. So from here, I will come here and add. So this is user. Come here. This is the name of the section. So when we click on add. So we can just draw a line. We close. So you can now see our section. You can now see our section. So let me just simply do a very simple this thing. Call this. Let me call this 2. This 5. Add. Then we go to this. No, 2 also. 2. Then we call this. Let's call this 20. Yes, let's call this 10 because we are making 2. Then for the Z we have 1. The first one, let's make it 9. Then the second one, we make it like 1.5. 1.5. Then we apply. Close. Okay, so let me define something here. Let me use, this is my extension. Okay, so I can copy, then I go to the rafter. Let me just want to use this to demonstrate. So come to offsets. Let me check offset display. Okay, it's just for demonstration. I just want to use it to demonstrate what we have done. So let's copy this. Okay, so let me just place the Z line. Let me copy it again and copy it, I think, along the x-axis. So let me see. Let me copy it by 1.2, comma. Let me copy it by 1.2. Let me make it up to 3. Okay. Okay. Okay, now it's not going to work this way. Let me just, I think that the most important thing is that I've been able to demonstrate this for you to see. That is the most important thing. I did not intend to do a very lengthy video. So that is the most important thing. Okay. So that is how you can create your cool form steel section and import it to Autobot, uh, Autodesk Robot structural analysis software. So thank you. I believe that you have learned something. See you in our next